Hello guys, so today we are going to be talking about the nature of matter. Alright, so subscribe to this channel if you are still new, and let's dive into lead. Alright, from our last class, you notice that we defined matter as anything that has mass and occupies space. Okay, so mass is measured in kilograms. Anything that could be measured in kilograms, then that occupies space. Virtually everything occupies space, even the gases and the air we breathe. It exists in three states: the solid, liquid, and gaseous state. Even though at advanced level we can add plasma. Alright, so the fundamental difference between these states of matter is the degree of movement of their particles. It is the degree of movement of their particles. Now the molecules of gases move randomly. They are the freest. They move free. Alright, they move in a zigzag and haphazard pattern. Then the particles of the liquid are less freer than that of gases. Okay, they take the shape of their containers. Alright, so while the particles of solids, they do not move at all, rather they vibrate at their mean position, right? And they have definite volumes. So we'll talk about the change of states from these states of matter. Now, when solid changes to liquid, it's known as liquefaction, melting, or fusion. When liquid changes to gas, it is known as vaporization. Now, when solid changes to gas without passing through the liquid state, it is known as sublimation. Now, when liquid changes to solid, it is known as solidification or freezing. When gas changes to liquid, it is known as condensation. Okay. Now, what are the properties of matter? The properties of matter are those characteristics and features that we can use to recognize matter. So these properties are divided into two. We have the physical properties and the chemical properties. Now, the physical properties are those things that you can observe generally. Okay, their color, their taste, their texture. For example, sand is rough, all right, and the color of iron is reddish brown. All right, the taste of banana is sweet, and the smell of ammonia is choking. All right, so these are the physical properties. You talk about smell, taste, touch, that's the texture. When you talk about the color and the rest, then when we talk about the chemical properties, these are how they react with other things in the environment. For example, nail undergoes rusting. So the chemical property of nail is what? Rusting. Then other chemical properties are also combustion and the rest. Okay, now we talk about changes. All right, because matter undergoes changes. Okay, we have two types of changes here: physical change and chemical change. Now, in physical change, it is easily reversible, and no new substance is formed. For instance, when ice changes to liquid water, there is no new substance that is formed. It is still that water. All right, the chemical composition is still intact. It's still H2O. All right, so what just happened was just change of state, and we can easily reverse it. But a chemical change, for example, when iron rusts, you see that it cannot be reversed, and a new substance is formed because iron has deteriorated into iron 3 oxide, and that is the basis for all the chemical reactions you are seeing when compounds and elements combine to form an entirely new compound. You get? So in every chemical change, there must be a chemical equation. So in the chemical equation, the left side is called the reactant and the right side is called the product. Okay, so the reactants are reacting together to form the product. So let's compare physical changes and chemical changes. Now, physical changes are reversible in nature, while chemical changes are not reversible in nature. So in physical change, there is very little or no absorption or evaporation of energy. But in chemical changes, there is absorption and evaporation of energy. Absorption means the taking energy, then evaporation means the give out. Reactions that absorb energy are known as endothermic reactions, while those that give out energy are called exothermic reactions. Now, in physical changes, the composition of a substance that undergoes physical change remains the same despite its molecules being rearranged. The composition, remember I told you that H2O as ice is steam, H2O as liquid water, but in chemical change it is not so. The chemical composition is altered. Now, under physical change, it does not form a new product or substance, but it is not so in chemical change. A new substance or product is formed. Now, in physical change, there is no change in the mass of the substance, but in chemical change, the new substances formed have different masses, but the total mass is unchanged. Now, under physical change, it is a temporary change, but in chemical change, it is a permanent change. Now, in physical change, it affects only physical properties, but in chemical change, it affects both physical and chemical properties. Under physical change, it does not involve the production of energy, while it is not so. In chemical change, it does involve the production of energy. Now, let's ask some questions. Dash is anything that has mass and occupies space. A. Matter. B. Mixture. C. Atom. D. Molecule. Next, which of the following is not a state of matter? A. Solid. B. Ice. C. Liquid. D. Gas. Next, dash is not a particle that makes up matter. A. Atom. B. Molecule. C. Metals. D. Ion. Next, dash depends on the amount of matter that is being measured. A. Electromagnetic properties. B. Biological properties. C. Intensive properties. And D. Extensive properties. Next, the type of properties that do not depend on the amount of matter is called A. Intensive properties. B. Extensive properties. C. Chemical properties. And D. Physical properties. Next, the properties associated with physical changes are dash properties. A. Chemical. B. Physical. C. Extensive. D. Intensive. Kudos to you and see you in next class.